Okay, so in this video we are going to be basically talking about physical quantities and also the ways in which we can classify these physical quantities. Alright, so to begin with, physical quantities are just measurable quantities. Okay, physical quantities are just simply measurable quantities. They are measurable quantities, these ones. In other words, anything that you can measure, mass, length, weight, density, all those things are generally termed as physical quantities. These are measurable quantities. That's the shortest definition that you can give them. These are measurable quantities. Okay? Now, on the definition part, that's what we can say. There isn't much about it. All those things that we just tend to measure, the volume, mass of an object, weight of an object, force of an object, all those things that you measure under physics, even under chemistry at some point, all those things are termed as physical quantities. They are measurable quantities. That's what you need to know. Now, these physical quantities can be expressed in many different categories or classified in many different categories, and this is what I just wanted to show you in this video. We won't get in depth, but try to understand. Well, physical quantities can be classified as being either basic or derived. Okay, so they are what we call basic quantities. Okay, there is what we call basic quantities, and there are also what we call derived quantities. Okay, so there are what we call basic quantities, and there are also what we term as derived quantities. Apart from expressing them as either basic quantities or derived quantities, physical quantities, in terms of magnitude and direction, okay, in terms of magnitude and direction, physical quantities can be expressed as either scalar quantities, and derived or other vector quantities. So that is in terms of magnitude and direction. So physical quantities can be expressed as either basic quantities or derived quantities, or the other way in which they can be classified they can be classified as either scalar quantities or vector quantities. So what can we say? What can we say about basic quantities? What can we say about derived quantities? Well, basic quantities, the simplest definition that you can give about them is that basic quantities are just single quantities. Basic quantities are just single quantities. They don't have any other quantities which make them up. They're just single quantities. And one thing that you need to know is that these basic quantities tend to have something which I like to call basic units. Basic units. Okay, basic units. So take note, basic quantities are just single quantities. They do not have any other quantities which make them up. Okay, and these basic quantities, as we are saying, are characterized by what we call basic units. Okay, they have what we call basic units, and I'm about to show you that in a moment. Derived quantities, on the other hand, are just the opposite of these basic quantities, which I'm just from saying. If basic quantities are single quantities, then it means that derived quantities are quantities which are made up of two or more basic quantities. Okay, derived quantities are quantities which are made up of two or more basic quantities, two or more single quantities, or if you want, you can say two or more foundational quantities. So derived quantities made up. These are made up of two or more basic quantities. Now, in physics and also chemistry, it's very much important that you are well familiar with the basic quantities that normally used. Okay, so let me just give you some basic quantities, common basic quantities that you just need to familiarize yourself with. Whether doing ordinary sciences, pure sciences, or even A-level sciences, you just need to know these basic quantities. The first one which I can talk about is mass. We can talk about mass. Mass is measured in kilograms. In other words, the SI units, okay? The SI units, the standard measured units of measurement here, or the standard units of measurement here are the kilograms. So the SI units for mass are the kilograms. SI units, these are just standard units of measurement, okay? Standard units of measurement. So mass is measured in kilograms. That's number one. Number two, we can talk about length. The SI units for length are just the meters. We can talk about temperature. We can talk about temperature. The units for temperature are just the kelvins. Number four, we can talk about electric current. Electric current. It's a winter though, so I hope you don't mind. So electric current, okay? Electric current is measured in amps. Okay, we can also talk about something which they call luminous intensity. Luminous intensity. Luminous intensity is measured with the SI units known as the candela. I hope this is the correct spelling though. Candela. We also have the amount of a substance. Okay, we also have amount of substance. Okay, we also have the amount of a substance. Okay, we also have the amount of a substance, and this amount of a substance is measured in moles. Okay, is measured in moles. And then the seventh one that we can actually talk about, which I think should have been maybe just in the beginning, just up there, we can also talk about time. Time is measured in seconds. Those are the SI units for time, the seconds. So basic quantities: mass, the kilograms, length, meters, temperature, kelvins, electric current, amps, luminous intensity, candela, and so on. Okay, so these are the 7 basic physical quantities. I've got to mention that. These are the 7 basic physical quantities. 7 basic physical quantities that you need to know. Okay, so physical quantities can be expressed in terms of basic quantities. Okay, basic quantities or derived quantities. Basic quantities, these are just single quantities. These are derived quantities, and these derived quantities are made up of 2 or more basic quantities. I said that single quantities are normally characterized by basic units. Derived quantities, on the other hand, are characterized by something which I might call derived units. Derived units. All these units that you see me put here are basic units: the kilogram, the meter, the Kelvin, the ampere, the candela, the moles, the seconds. All these are basic or single units of measurement here. Examples of derived units, you should be very careful. Examples of derived units, we can talk about the meter per second. We can talk about the meter per second squared. We can also talk about the Newton. We can also talk about the joule. There are many which I can just put here. So the meter per second squared, the Newton, the joule, all these are examples of what I'm referring to as derived units. What are the derived quantities which we apply these units on? Meters per second is strictly for velocity slash speed. Velocity slash speed. The meter per second squared refers to a certain physical quantity, derived for that matter, known as acceleration. Okay, known as acceleration. The Newton and the joule are mostly exaggerated by many, misunderstood by many. They think as if maybe these are basic units. The Newton and the joule, people think as if maybe these are basic units, but well, they aren't. Well, the Newton that we see here, originally, this one is written as kg, meters per second squared. These are the original units for force, the kg meters per second squared. Now, just to show appreciation to the person who, let me say, did much of the work concerning forces, the kg meter per second squared was substituted with the N symbol for Sir Isaac Newton, kg meters per second squared. So again, the Newton here, the kg meter per second squared, is pointing out to this derived quantity known as force. Okay, known as force. The same thing also applies to the joule. It's not a single unit. It's not a basic unit. This is a derived unit. Originally, this is kg meters per second squared. In fact, it's kg meters squared per second squared. Okay, kg meter per second squared, that's force, and kg meters squared per second squared. This is the original unit for work, energy even, all right? But because of a certain man who had contributed much to establishing this, there was a man by the name of James Prescott Joule. James Prescott Joule. He introduced something which we call Joule's law. Okay, he introduced something which we call Joule's law when he was talking about heat energy. So kg meters per second squared, this is just pointing out to either work or energy. Okay, pointing out to either work or energy. So this was the guy, James Prescott Joule. In one of our videos under electricity, we'll make sure that we talk about what this guy had said. Okay, so in this video, basically, I'm just going to talk about basic quantities, but in the next video, definitely, we are also going to establish what scalar quantities are and what vector quantities are. Thank you very much.